All right, this video is on solving what we call a literal equation. Now, the good thing about this is it's really all we've been doing before, solving one-step equations, solving two-step equations, solving multi-step equations. But the thing about a literal equation is that your answer usually doesn't come out to be a number. So we're solving for a given variable, like normal, but we might have other variables in our problem that we're not going to get x is equal to 7. It's going to equal something different. So to solve a literal equation, it's really going to be like what we did before. We're going to locate the variable that we want to solve for because there may be more than what we're given. And then all we do is we follow all the same rules to get to that variable all by itself. So let's look at this example. It says solve for x. You're always going to be told what you're solving for. In this case, it is x. So we go here into our original equation and we look, where is the x? It's right here. So I want to get that x all by itself. But notice that there's a plus b and it's equal to a. There's no numbers in this. We're essentially setting up a formula for how do we solve for x if we know everything else. So we do, if I have x here, it has this plus b. So I want to get rid of that b. But it's a plus b. So we do just what we would normally do if we were adding in a number. We would do the opposite. So instead of adding b, we're going to subtract b from both sides. B plus b, no matter what it is going to cancel out and go away. And you're going to be left with a minus b. Well, I don't know what a is, so I can't subtract. I can't do that subtraction right now because I don't know what the letter a is. So we just write it as a minus b. We get our answer then. This equation solved for x is x equals a minus b. We're done. We didn't have to use our calculator. We didn't have to do any adding, subtracting, multiplying, or dividing with actual numbers. We just write it out as a formula. We can do something like this. Solve for d. I have CD. Remember, if a number is right next to each other, it means it's multiplying equals 10. We want to get d all by itself, so we locate our d, the variable that we're looking for. Now this is multiplying, so we said the opposite of multiplying is division. So we divide both sides by c. C divided by c, no matter what number that is just 1. So those cancel out. But if whatever I do here, I have to do on the other side. I don't know what c is, so I can't actually do that division. So we do 10 divided by c. D is equal to 10 divided by c. And we're done. We didn't have to do any computation of numbers. Let's look at one more example that's worked out for us. Solve for a. We have 4a minus b equals c. So we want to solve for a. We locate a. We circle it or underline it or something. Now we want to get anything that is not an a over to the other side. So here we're subtracting b. So we use the opposite. Opposite of subtraction is addition. We add b to both sides. That gives us 4a is equal to c plus b because we don't actually add those out. We just write it like c plus b. Because I don't know what those numbers are, so I can't add them. Now we want to get rid of this 4 because we want to get a all by itself. To get rid of this multiplication, a number right next to a variable is multiplying, so we divide both sides by 4. Divided by 4. I don't know what these numbers are again, so we just write the division bar or the fraction bar and write a 4 under it. Our final answer for this is a equals c plus b minus 4, or divided by 4. That's it. All right, let's look at a couple more examples. Here I have k plus 20 equals t, and we want to solve for k. We identify where our variable is. So here's our k. We want to get it all by itself. We're adding 20. The opposite of adding 20 is going to be subtract 20 to get rid of that. But whatever I do to one side, I have to do to the other side. Those go away. That leaves me with k on this side equals t minus 20. I don't know what t is, so I can't do that subtraction, so we just write t minus 20. There is our answer. That's the equation solved for k. Over here, I have v divided by 5. Remember, a fraction means division. V divided by 5 equals W. We want to solve for V. There's our V. To get rid of this division, we have to do the opposite and multiply both sides by the denominator, or 5. Those cancel out. But whatever I do to one side, I have to do to the other side. So if I multiply this side by 5, I have to multiply that side by 5. That gives me V equals, whenever we do a variable times a number, we generally put the number first. So we would do 5W, and we're done. We're solved for V. Solve for M. 2M minus P equals 11F. Here's my M. The first thing that I'm going to do is I'm going to get rid of anything that does not have a M attached to it. So it's this minus P. So we're going to add P to both sides. Those go away, leaves us with 2M equals 11F plus P. Well, I don't know what F and P are, so we just write it as 11F plus P. Now we're not quite done because this M right here has a number attached to it. It's 2. It's being multiplied by 2. We're going to divide both sides by 2 then. Opposite of multiplication is division. But then I'm going to divide this whole side by 2. That leaves us with M equals 11F plus P divided by 2. That is our final solution for that one. One more example that we're going to go over. Solve for y. Here's my y tucked in the middle between there. The first thing that we're going to do is we're going to get rid of anything that doesn't have the y attached to it. So it's this a. We're adding a, so we're going to subtract a from both sides of our equation. Goes away. We have 11x y z equals 10 minus a. I can't do that because we don't know what those values are. Both this x and z are being multiplied by that y. Remember, the order doesn't matter. So both x and z are being multiplied by y. So to get rid of it, we're going to divide, and we can divide by both the x and the z at the same time. And if I do that, I could do the same thing on the other side. Divide both sides by x over z. This x crosses out with that x. That z cancels out with that z. All we're left with is y equals 10 minus a divided by x over z. Because we can't actually do those computations, so we're done there. Now the idea of this, as it says down here, is so we can manipulate common formulas. This is a formula for perimeter of a rectangle. The perimeter is equal to 2 times the length plus 2 times the w. Well, what if I know the perimeter and I know the width? We could use that to find the length. We're going to talk about other formulas that we can use to solve these with. So common formulas, as you move on into other classes like geometry, we manipulate formulas a lot to get what we need to solve for. Something like this. This would be a geometry formula. And that concludes this video.